Welcome to the video on chemical nomenclature. When we have a molecule, we want to be able to name it in a very specific way so that everyone is talking about the same thing. Remember, a molecule is two or more atoms in a definite arrangement held together by chemical bonds. Recall also, we have 7 diatomic elements: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. One way to remember this is help our needy class find its brains. That's just a quick little way to remember all of them. The other thing I showed you was the pattern of the 7 on the periodic table. We know molecular mass, that's the sum of the atoms in all the molecules. There are 2 atoms that bind together in a different way other than the diatomics, and that is sulfur, which gets together with 8 atoms, and phosphorus, which gets together as 4. There are a couple examples of molecules that have a common name that we will need to know. Water is H2O, ammonia is NH3, methane is CH4, and ozone is O3. Those are the only common names you'll have to know. Everything else in this course will be systematic. So next up is polyatomic ions. A polyatomic ion is a group of atoms held together by covalent bonds that exist as a group but have a charge. For example, hydroxide, which is shown right here. That is an O bound to an H, and that has a negative charge. So now we can think about that as an entity that has a negative charge. That is shown right here on the table. So basically, there's no getting around it. We have to memorize these polyatomic ions. Another one I want to show you is NH4. That's called the ammonium ion, and it exists like this, and the whole thing has a positive charge. And so that now is going to act as a single entity. Even though it's 5 atoms, it's going to act as ammonium ion. Now, the next thing I want to talk about in this chapter is predicting ionic compounds. And the first example we'll talk about is NaCl. When we have sodium and chlorine and we put that together, it's going to exist in one way. We recall it's an ionic bond because one is a metal and one is a nonmetal. But if we think about where is sodium on the periodic table, sodium is in group 1, and so it will have a positive charge in its stable ionic form. Chlorine is in the halogens. It's over here in group 7, and it has a negative charge in its most stable ion. And so if you have a +1 getting together with a -1, they're going to do that in a 1-to-1 ratio. So our formula here is going to be NaCl. We always list the positive ion first and the negative ion second. Now, if we go down to calcium bromide, if we find calcium on the periodic table, it's here, and that has a +2, whereas bromine is here, and that has a -1. So what happens is, in order to get the charges to cancel, we're going to do the crisscross, where I take this 1 in its absolute value and put it down here, and take this 2 in its absolute value and put it down here. So what calcium bromide looks like, CaBr2. You do not have to write the 1. You only have to write if there's 2 or more atoms of the same thing in an ionic compound. So that formula would be CaBr2. Now let's try potassium and sulfur. Where is potassium on the periodic table? Potassium is right here. So that is going to be K+. And where is sulfur on the periodic table? That is shown right here. So that is going to be S2-. So if we do the crisscross, we do K2S1, or we don't write the 1. So it becomes K2S. Now let's try aluminum oxide. Where is aluminum on the table? Aluminum is shown right here. So that's a +3, and it's Al. So we're going to do Al3+. And oxygen is right here in group 6. So that is oxygen 2-. And if we do the crisscross, it looks something like this: Al2O3. And that now becomes aluminum oxide. So basically, we need rules for naming compounds so that all scientists are able to communicate in the same language. The organization that is in charge of naming is called IUPAC, which stands for International Unions of Pure and Applied Chemists. So if we start talking about the rules for naming, the first step in that is determine what type of compound we have. And there are 4 types of compounds. The first is binary covalent, and that means that we have a covalent molecule where we have a nonmetal bound to a nonmetal. The second example is binary ionic, and this is when we have a metal bound to a nonmetal. So it's the same as the ionic compound we talked about earlier. Thirdly, we have an ionic compound that has a polyatomic ion. Remember, I just showed you the table of polyatomic ions. We're going to be able to use those polyatomic ions when we're making molecules. And then finally, we have acids. Right now, I'm going to discuss how we name these 4 types of compounds. Bottom line, we're going to use the rules for each type to name the compound. But look at the bright side. We've made a flow chart here to help you figure out how to name. And I'll have a handout in class for this as well. So here's covalent bonds, ionic bonds, and these ionic bonds could also include the polyatomics and then the acid. We're going to start by talking about binary ionic. So this is a metal and a nonmetal. We always list the positive ion first, and that's very typically a metal cation. Then we name the second element, and then we write the IDE ending to the name. So we take the stem name and we change it to IDE. That means negative ion. The negative ions are very typically the nonmetal anions that we talk about on the periodic table. When we're writing the formulas, we can't forget the charges. So if we are going to determine the name for LIBR, we start with the name of the first element. So the cation is lithium, and the anion here, remember we add the IDE ending, is going to be bromide. So LIBR is named lithium bromide. If we try the second one here, the SR stands for strontium and the F is fluorine, but we need to turn that into fluoride. Just wanted to make a quick note at this point in nomenclature, when we have binary ionic, we do not have to worry about indicating how many fluorines are in it in our name because it's implied by the charges. And now, if we're given the name aluminum chloride, we need to figure out how to draw that compound. And the first thing we're going to do is aluminum and chloride. And now we have to figure out how they go together. Aluminum is in group 3, so that's going to be a +3 charge. And chlorine is in group 7, so that's going to have a -1 charge. And so if we do the crisscross, it will look like AlCl3. The second type of binary ionic compounds involves transition metals. So these are metals not in group 1 and group 2. And so remember, we talked about those transition metals being able to have a number of different ions. The way that we distinguish the specific ion that's used in that molecule is using Roman numerals. We use that Roman numeral to indicate the charge that's on our atom. So the first one we're going to do is copper chloride. Chlorine is in group 7, so that's going to have a -1. And so that dictates the charge that the copper has to have if they are at a 1-to-1 ratio. If chlorine is -1, then copper also has to be +1. And so we're going to call that copper 1 chloride. A second example, if we have iron 3 bromide, we would have to look at iron is Fe, and that's going to be 3+, and the bromine is -1. And so if we're going to write iron 3 bromide, we would do the crisscross in this way, and we'd end up with FeBr3. So when we're writing the formula from the name, we know that copper is 2+, and we know that chlorine is 1-. When we do the crisscross method, we end up with copper 2 chloride, and that looks like that. The third way that we can look at ionic compounds is with polyatomic ions being part of our molecule. So if we are given the name sodium nitrate, we know that sodium is Na, and we know that nitrate is NO3 from the polyatomic ion table. Sodium is +1 because it's in group 1. If we look at the table and are ultimately memorized, nitrate is going to be -1. And so those go together 1-to-1, and it's NaNO3. So if we look at our polyatomic ion table, we see that NH4 equals ammonium. So that is the beginning of our name, ammonium. That has a charge of +1. And then we look up SO3, and SO3 equals sulfite, and that sulfite has a 2- charge. And so that would make sense if we did the crisscross. NH4 taken twice and SO3 taken once. But to name that, we have ammonium sulfite is the answer. So now if we move on to the next example where we have the name aluminum sulfate and we have to draw the formula, aluminum is Al, and that is always 3 plus. And sulfate, if you look at the polyatomic ion table, becomes SO4. That one has a 2 minus charge. So if we do the crisscross here, we end up with Al 2 SO4 taken 3 times. And we need to draw those parentheses in so we know that that whole polyatomic ion is taken 3 times. So there's the 3 ways that we can name ionic compounds. One is a straight ionic compound that forms from a nonmetal and a metal, and the metals primarily coming from group 1 and 2. Then we have the transition metals where we use Roman numerals. And then we have the polyatomics where we have to memorize from the table. And so if we move on to binary covalent, remember these are going to be the covalent bonds that exist between 2 nonmetals, both above the step. So in this case, we're going to name the first element listed in the formula, and then we're going to add IDE to the second element. And the difference with this one, we're going to use prefixes di, tri, tetra, etc. in order to talk about the number of atoms we have for each. And here is a table that tells you the prefix that goes along with each of the numbers. If we have a single, it's mono. If we have 2, it's di. If we have 3, it's tri. 4 is tetra, and so on. So if we look at the first example, if we are given NO, then we can name that nitrogen oxide. There's just one of each. You don't have to put the mono in. So that example is just nitrogen oxide, NO. In order to draw the formula for nitrogen dioxide, we can talk about nitrogen and we can talk about oxide, and now we have to decide what subscripts we're going to put in. So if we just have 1 nitrogen and then 2 oxygens, that is going to be NO2, nitrogen dioxide. And so in the last example here, P stands for phosphorus, and O stands for oxygen, which is going to be oxide. And so now to put our prefixes in, phosphorus is di and oxygen is tri. So the full name for this compound is going to be diphosphorus trioxide, diphosphorus trioxide. So this is when we have covalent bonds. We're going to use di-tri-tetra in order to indicate our subscripts. And lastly, we're going to talk about naming acids. Remember, acids are proton donors. There are 3 types of acids, and these are going to be the ions that are formed when we remove a proton. And the 3 types are going to be IDE from the periodic table, ATE from the polyatomic ions, and ITE from the polyatomic ions. So the ide would be for chloride, fluoride, bromide. And whenever we have an acid made from an ide anion, they are called hydrobromic, hydrochloric, hydrofluoric acid. So with HCl, that is hydrochloric acid. If we're going to use the example where we have sulfide ion, S2 minus, then that is going to be called hydrosulfuric acid. And so the name for this one, the acid would be H2S. We need the 2 because the S is 2 minus, and that is going to be hydrosulfuric acid. So IDE becomes hydroblankic acid. From the periodic table, we'll know the charge so we can know how many protons, and then we write hydro at the beginning of the name. So the bottom 2 examples are from the polyatomic ion table. Acids made from the ATE ions are going to be ic acid. For example, if we have the nitrate ion shown here, it has a -1 charge, so we have HNO3, and that is going to be called nitric acid. If we have the acid that's made from the sulfate ion, because that's a -2, we are going to have H2SO4, and that is going to be called sulfuric acid. And finally, if we have the ITE ions, then we're going to call it an US acid. Using the nitrite ion shown here, that has a -1 charge, so there's 1 proton, so it's HNO2, and that would be called nitrous acid. If we're looking at the sulfite ion over here, because it's a -2, we are going to have H2SO3, and that is going to be called sulfurous acid. A quick recap for acids: IDE is hydro whatever ic acid, ATE is ic acid, ITE is us acid. One quick way that I remember, at least this one right here, is the little saying that I ate it and it was icky. Take it or leave it. Now we're going to spend class time working on the practice problems on the next 2 pages here. There you have it, nomenclature. Good luck.